In recent months, information has begun emerging around one of the most ambitious space companies in the world that could radically change humanity's understanding of interplanetary travel. According to several sources, including industry publications, analytical centers, and leaks from engineering circles, SpaceX is indeed working on a fundamentally new engine technology that could reduce the flight time to Mars from the usual 6 to 9 months to just a few weeks. And although the company officially continues to focus on its massive Starship system and Raptor chemical engines, insiders claim that behind the scenes a much more radical solution is being developed: a next-generation fusion engine, unofficially known as AeroFusion. The core idea behind this technology is the use of controlled nuclear fusion not to generate electricity, as is currently being explored in the energy sector, but directly to create thrust. This means that instead of burning fuel, as modern rockets do, the engine uses the enormous energy released during the fusion of light atomic nuclei. In theory, such a system could generate thrust orders of magnitude greater than any existing solution, while providing an incredibly high specific impulse. This parameter is one of the most important factors in space travel because it determines how efficiently an engine uses fuel. Acording to information appearing in several technology publications, AeroFusion represents a hybrid between a compact fusion reactor and a plasma accelerator. At the center of the system is a reaction chamber where conditions similar to those found inside stars are created. Temperatures reach tens of millions of degrees, and maintaining plasma in such conditions is only possible with the help of extremely powerful magnetic fields. That is why the reactor is surrounded by a complex system of superconducting magnetic rings that create what is known as a magnetic confinement system. The plasma does not touch the walls of the chamber, but remains suspended, which prevents the destruction of the structure. Then, the most interesting part begins. Unlike traditional fusion systems, where the energy from the reaction is converted into heat and then into electricity, AeroFusion uses direct conversion of energy into thrust. Charged plasma particles are directed into a nozzle using magnetic fields and accelerated to enormous speeds, creating propulsion. Essentially, this is not just an engine, but a controlled stream of energy transformed into motion. If the calculations discussed in closed engineering circles are accurate, such an engine could provide enough acceleration for a spacecraft to not simply accelerate and then coast toward Mars as current missions do, but to continuously accelerate for a significant portion of the journey and then actively slow down in the same way. This is what would reduce travel time to just a few weeks. Some estimates even suggest the possibility of reaching Mars in around 14 to 20 days, something that until recently was considered completely impossible. However, behind these numbers lies a huge range of technical challenges that have still not been solved. The biggest one is the stability of the fusion reaction. On Earth, scientists have spent decades trying to achieve sustainable and controlled fusion, and only in recent years have the first major breakthroughs appeared in this field. Moving such technology into space, making it compact, reliable, and safe, is a task that requires fundamentally new solutions. Another challenge is cooling. Even though plasma does not come into contact with the reactor walls, the system itself experiences enormous thermal loads. In the vacuum of space, removing heat becomes a separate engineering challenge. According to rumors, the solution may involve massive radiators that would unfold in space and release heat through radiation. Radiation is another critical issue. Fusion reactions produce streams of high-energy particles that could pose a danger to a crew. This means that the spacecraft would need to be equipped with a complex protection system, including shielding and possibly the use of magnetic fields to deflect charged particles. Interestingly, some sources claim that SpaceX is considering integrating AeroFusion into future versions of Starship, or even developing an entirely new class of spacecraft specifically designed for this type of engine. Such vehicles could become the first true interplanetary transport systems, capable of performing regular flights between Earth and Mars. In terms of cost, in the early stages it would be enormous. The development, testing, and certification of such an engine could cost tens, if not hundreds, of billions of dollars. However, in the long term, the technology could radically reduce the cost of interplanetary travel. Faster missions would mean lower life support expenses for the crew, reduced risks, and the possibility of more frequent missions. The main revolution of AeroFusion is not only speed, it is about a complete transformation of the logic of space travel. Today, a mission to Mars is a rare event requiring extensive preparation and massive resources. With such engines, interplanetary flights could become routine. This opens the way to permanent colonies, the development of an interplanetary economy, and possibly an entirely new industry. According to analysts, if SpaceX truly manages to realize such a technology, it would be a moment comparable to the introduction of the first jet aircraft on Earth. It would mark a transition from an era of slow, expensive, and risky flights to an era of fast and relatively accessible travel. Nevertheless, it is important to understand that at present, AeroFusion remains a concept, albeit a highly promising one. There is no official confirmation of such an engine being developed, and all leaks and insider information should be treated with a degree of skepticism. But the very fact that such ideas are being discussed at the level of leading engineers and companies suggests that humanity is indeed standing on the threshold of a new era in space exploration. And even if the first version of such an engine does not appear tomorrow, but in 10 or 20 years, it would still mean that the path to the stars has become significantly shorter. Perhaps it is precisely such technologies that will ultimately turn Mars from a distant and unreachable goal into the next step in the evolution of human civilization. However, as information about the AeroFusion project begins to leak into the public domain, an increasing number of experts are focusing on one extremely important aspect. If this technology is indeed at least at the prototype stage, it would mean that a fundamental shift has already occurred within SpaceX in how future transportation is being understood. This is not just about a new engine, but about a transition from the chemical era of spaceflight to an energy-based era. And this distinction is fundamental. Chemical engines are limited by the energy of chemical bonds, whereas nuclear fusion operates with energy that is orders of magnitude higher. It is the difference between a campfire and a small sun contained within an engineered structure. According to sources close to the aerospace industry, in recent years, SpaceX has been actively building expertise not only in rocketry, but also in adjacent fields: materials science, cryogenic systems, plasma control, and high-temperature electronics. These seemingly separate areas are in fact key components of a future fusion engine. This is why some analysts believe that preparation for such a breakthrough may have been underway for much longer than it appears, simply hidden under the cover of other projects. Of particular interest is the possible architecture of a spacecraft equipped with AeroFusion. Unlike modern rockets, where the engine is just one part of the system, here it becomes the central element of the entire structure. In effect, the entire spacecraft is built around the reactor. Living modules, cargo sections, and control systems are placed at a maximum distance from the radiation source, connected by a long structural truss. This not only reduces radiation exposure for the crew, but also allows for optimized mass distribution. In addition, such a spacecraft, according to preliminary concepts, would be capable of continuous maneuvering in space. This means that flight trajectories would no longer be strictly tied to launch windows, as is currently the case. Missions to Mars could be carried out almost at any time, which fundamentally changes the entire logistics of interplanetary travel. Space effectively shifts from a domain of rare opportunities to one of continuous transport flow. Another highly interesting aspect is the question of fuel. Fusion reactions typically involve hydrogen isotopes such as deuterium and tritium, or more advanced options like helium-3. Some sources claim that SpaceX may be considering hybrid schemes that would allow the use of more accessible fuels in the early stages, with a gradual transition to more efficient but rarer isotopes. This opens an entirely new field, space resource extraction, including the moon and asteroids. If we consider the broader impact of AeroFusion on the industry, it could be comparable to the emergence of the internet or electricity. Fast interplanetary travel would not simply mean Mars exploration, but the creation of a full-scale space economy, cargo transport, resource extraction, scientific missions, tourism, all of this becomes realistic within a horizon of 1 to 2 decades after the technology is introduced. But alongside this come new risks. A technology capable of generating such enormous amounts of energy inevitably attracts attention beyond the civilian sector. Issues of space militarization become particularly sensitive in such a scenario. An engine capable of accelerating spacecraft to extreme speeds could theoretically be used for other purposes as well. For this reason, many experts believe that the development of such systems will inevitably lead to new international agreements and regulatory frameworks. Meanwhile, according to some insiders, initial ground tests of key AeroFusion components could begin in the coming years. This does not yet involve a full-scale reactor, but individual elements, magnetic systems, plasma confinement chambers, and nozzle prototypes are reportedly already being tested in secure laboratories. If these data are confirmed, it would mean that the project is much further from the conceptual stage than is commonly believed. It is also being discussed that initial orbital tests without a crew could be conducted. Such a demonstrator vehicle could become an important step toward the creation of a fully operational interplanetary spacecraft. It would allow engineers to test engine behavior in vacuum conditions, evaluate operational stability, and identify potential issues. Interestingly, Elon Musk himself has repeatedly stated that the ultimate goal of SpaceX is not merely to transport humans to Mars, but to establish a self-sustaining civilization beyond Earth. And if AeroFusion is considered in this context, it becomes clear that without technologies of this level, such a goal is practically unattainable. Fast and reliable transportation systems are the foundation of any colony, especially when it involves another planet. In the long term, such engines could open the path not only to Mars, but also to more distant destinations. Flights to the moons of Jupiter and Saturn, exploration of the asteroid belt, and in a more distant future, even interstellar missions. What today seems like science fiction is gradually beginning to take the shape of engineering projects. That is why around AeroFusion an information vacuum is already forming, filled with rumors, leaks, and speculation. On one hand, this fuels interest and creates a sense of an approaching breakthrough. On the other hand, it makes it more difficult to distinguish where reality ends and speculation begins. But the history of technological revolutions shows that the most radical ideas are often first perceived as fantasy and then suddenly become the new normal. And if even half of what is being discussed today regarding AeroFusion turns out to be true, it would mean that humanity is standing on the threshold of the largest leap in the history of space technology. A leap that will change not only how we travel, but how we perceive space itself. Space will cease to be distant and hostile, becoming the next habitable environment open for exploration. And perhaps, in a few decades, when the first regular flights between Earth and Mars become a routine part of life, we will look back on these early rumors and leaks as the moment when it all began. The moment when the idea of an engine capable of transporting a human to another planet in a matter of weeks first stopped being fantasy and began turning into reality. But there is another aspect that is rarely discussed in public discourse, and which may turn out to be key to understanding the true scale of the AeroFusion project. It relates to the fact that such an engine could potentially transform not only the space industry, but also the very structure of the global economy. The point is that once travel between planets becomes fast and relatively accessible, the concept of distance in space effectively disappears. Mars stops being a distant expedition and becomes the next logistical hub connected to Earth through a regular transport flow. According to some analysts, if AeroFusion is successfully realized, the cost of delivering 1 kilogram of cargo to Mars could drop significantly compared to current Starship projections. This, in turn, opens the possibility for large-scale infrastructure development, from living modules to industrial complexes. And this is where the next stage of transformation begins. Mars ceases to be merely a scientific base and becomes a fully fledged economic region. Inside SpaceX, according to rumors, scenarios are already being considered in which AeroFusion becomes part of a broader ecosystem that includes orbital stations, automated factories, and resource extraction systems. In such a scenario, spacecraft turn into a kind of interplanetary freight trucks, capable of regularly shuttling between Earth, orbit, and Mars at high frequency. This is no longer a series of individual missions, but a full transport network. But this also raises an even more ambitious question. What comes next? If the technology truly achieves such high speed and efficiency, the next logical step would be expansion beyond Mars's orbit. The asteroid belt, rich in rare metals, begins to be seen as a potential resource source. And this represents trillion-dollar markets capable of reshaping the balance of power on Earth. Interestingly, some futurists already draw parallels between the possible emergence of AeroFusion and the era of great geographical discoveries. At that time, new navigation and shipbuilding technologies allowed humans to cross oceans and discover new continents. Today, we are at a similar point, only the oceans are replaced by space. And while previously, such journeys took months and were extremely dangerous, with the arrival of new engines, they could become fast and relatively safe. However, there is also a more grounded but equally important factor: the human element. Faster travel means crews will spend significantly less time in space, reducing exposure to microgravity, radiation, and psychological isolation. This not only makes missions cheaper, but also far safer. In the long term, this could open the door to regular crewed flights where humans travel to Mars not as pioneers, but as specialists, engineers, scientists, and even entrepreneurs. And at that point, it becomes clear that AeroFusion is not just an engine. It is a transitional step toward a new phase of civilization's development, a phase in which humanity is no longer bound to a single planet and begins to truly explore the solar system. But like any technology of this magnitude, it will require time. The first versions may be far from perfect, unforeseen problems and delays may arise. However, the very fact that such developments are being discussed at the level of major technology companies and research centers indicates that the direction has been set. And if one day, news truly emerges that SpaceX has conducted the first successful tests of a fusion engine for interplanetary travel, it will mean that humanity has taken one of the most important steps in its history, a step that has brought us not only closer to Mars, but closer to the stars. Meanwhile, as informational noise around AeroFusion continues to grow, a growing number of experts in the field are increasingly suggesting that the real revolution could happen even earlier than many expect. The point is that such projects rarely emerge from scratch. As a rule, they are the result of years of hidden work distributed across dozens of parallel directions. And if one combines all the indirect signals, investments in new materials, rising interest in superconductors, and active research in plasma physics, it becomes clear that the industry as a whole has already begun moving toward thermonuclear solutions. According to former employees of aerospace companies who agreed to comment on the situation on condition of anonymity, SpaceX may be leveraging its main strategic advantage: development speed. Unlike government agencies, where projects stretch over decades, Elon Musk's company is known for being able to move from concept to prototype many times faster. This means that even if AeroFusion is still at an early stage, its development could be exponential. It is also interesting that in recent years, SpaceX has been actively expanding its manufacturing capabilities, including new research laboratories and closed test sites. Officially, they are associated with the development of Starship and related technologies, but some analysts suggest that key elements of a future fusion engine could be tested there, particularly plasma magnetic confinement systems and high-temperature materials capable of withstanding extreme loads. If we move from theory to possible practice, the first versions of AeroFusion would likely be far from the performance figures currently discussed by insiders. Real-world capabilities could be more modest. For example, reducing travel time to Mars not to 2 weeks, but to 1 or 2 months. However, even this would represent a colossal breakthrough. It is important to understand that in technologies of this level, progress occurs in stages. First, a working version appears, then it is gradually improved, and only years later does it reach its full potential. Nevertheless, even a simplified AeroFusion could radically change the strategy of Mars exploration. Instead of rare and extremely expensive missions, it would become possible to organize regular deliveries of cargo, equipment, and people. This would mean that the construction of a Martian base could move from an experimental phase to an industrial one, enabling large-scale infrastructure deployment, including energy systems, manufacturing facilities, and residential complexes. And if today the idea of a 14-day trip to Mars sounds like science fiction, tomorrow it may become the new normal. In this sense, AeroFusion is not just a future technology, it is a signal that humanity is beginning to transition from the stage of exploration to the stage of true expansion, from first steps to real forward movement. And perhaps this transition will become the most important moment in the history of the space age.